Greetings to whomsoever it may concern. So here we are going to see an important topic, that is Leidenfrost effect. Now, it is so common in our households that it is often ignored by us. See, it is in our kitchens and it is used in our daily life 2 to 3 times, and yet we are not able to know the reason behind it, and we are not able to even see it. So it was founded by Johann Gottlob Leidenfrost in 1756. Imagine 300 years, and still we're not able to understand the meaning about it. So let's basically take an example. Now imagine you want your mother or your grandmother, they want to make a dosa or chapati. So what they do basically, so to test whether the pan they are cooking on it is hot enough, they sprinkle some water droplets on the pan. Now if the water droplets they fall on the pan and evaporate, then the pan it is not hot enough. But if the water droplets retain on the pan and dance and sizzle like the pan is not hot enough, but it is, then the pan it is hot enough. So in simple words, what we are observing is Leidenfrost effect, and it is so ironic that the pan is hot enough and then also the water droplets they are being retained on the pan. So let's see the reason behind it. What is now? In the case of water, the boiling point of water is 100 degrees Celsius, and we all know about it. Now suppose the pan it is 90 degrees Celsius, or for a matter of fact it is 100 degrees Celsius. What happens? As soon as the water droplet it falls on the pan, it evaporates like this. It evaporates and we are not able to see it because the boiling point is matched and it evaporates. But suppose we increase the temperature of the pan to 200 degrees Celsius, or for a matter of fact to 50 degrees Celsius. Now this is our pan, water droplets form. As soon as the water droplet it comes in the contact with the pan, the lower portion or some portion of the water droplet it converts into steam or water vapor, and this it acts as a cushion or an insulation between the pan and the water droplets. Now because of this insulation, apt amount of heat is not being provided to the water droplet, as steam it does not have much particles in comparison to liquid, because it's a type of gas only. It's not a gas, but it is basically water vapors. Now water vapors, of course, particles are very less in water vapors. Now what happens basically, as a cushion or an insulation layer is formed, so and the water vapors it has a conduction which is 30 times less than of liquid. So apt amount of heat is not being provided to the water droplet, and it starts to move around the pan and sizzles. It dances basically, and the whole phenomena is very interesting. You must try it. Now people think that this phenomena it is very simple. It does not have any implications. Actually, it does not have an implication, but it can be proved disastrous. In the case of nuclear power plants, they are basically rods which get hot to provide heat to the whole nuclear power plant. But if these rods they get very hot, it can be disastrous, of course. For example, Fujiyama, it was a nuclear plant was there and it basically blasted, which killed hundreds of people. Now this rod, what happens when it gets hot? What basically the people do, they drop water droplets on it. Now it is reasonable because evaporation it causes cooling. But now what happens? This rod it has a temperature which is very much than the boiling point of water, which is about 200 to 250 degrees Celsius, or even 150 degrees Celsius. What happens? As soon as the water droplets they fall on the rod, the Leidenfrost effect happens and the water droplets retain. The rod is not able to get cooled, and the whole nuclear power plant it bursts, and that's a very bad effect. And after knowing what is Leidenfrost effect, people were able to construct engines in jet planes, or for a matter of fact these rods in nuclear power plants, by a material that gets hot at very low extent. Basically it retains the heat, and because of that Leidenfrost effect was not visible. And Leidenfrost effect, it is not concentrated to water. It also happens in dry ice or liquid nitrogen. Now in the later part of the video, you'll see this experiment on a pan. You see it and give your feedback on it. Thank you, everyone. So here the temperature of the pan is around 100 degrees Celsius because we have just started boiling it, and as we pour it, you can see the liquid evaporates to form the vapors. And yeah, now we boil, or basically we keep the heat on for 5 minutes, and the temperature increases to 250 to 200 degrees Celsius about. And here Leidenfrost effect is visible, where this huge bubble is formed because of the insulation or cushion layer that is formed the steam just below this huge droplet that has been formed. Leidenfrost effect, it has not only harms but also many advantages. In Leidenfrost effect, the water droplets remove due to the vapor layer present beneath them. Now, this movement of water droplet can be controlled by hitting the surface and making grooves over it. This controlled movement can be used in various different fields. Firstly, in soft robotics, where the cost is very low, and we can use these water droplets to control the locomotion of the robots. And not only that, in chemistry, we have to move the biological or the chemical samples without contamination. So these droplets can assist in the movement of these samples without contamination because no human involvement would be required. So this was Leidenfrost effect. Thank you.